When light travels through a double slit, we get an interference pattern on a screen set some distance away. The fact that we get an interference pattern confirms that light is a wave. Thomas Young gets credit for the experiment way back in 1801. The double slit, the subtle differences in the distance from one slit to the screen compared to the other slit to the screen, those subtle differences end up with regions of constructive interference and regions of constructive interference and regions of destructive interference. There's an actual image taken during class when we were working on the lab. You can see the double slit, they make smudges of light. They've got some width to them. They're evenly spaced and they gradually fade from bright to dark. The brighter ones in the center, the darker ones out to the outside. When we did the math on the double slit, we got the conditions. If we're considering the angle, then our equation is d sine theta. If we're considering the distance measured along the screen, the y value, then our condition is dy over L. For constructive interference, that d sine theta or dy over L is always a multiple of lambda. For destructive interference, that distance is always off by a half. Since things are so evenly spaced, we'll often use the geometry or a bit of logic to figure out how far apart bright spots are or how far apart the dark spots are. If we can find the distance between a consecutive bright, so say here to here, or if we can find the distance between consecutive dark, so say maybe here to here, that's equivalent to saying where the first bright spot is, which is really the n equals 1 condition. Let's do an example. I've put the picture back up there so we can figure out that first to fifth, what that all means. But before we get to that, the question gives us the wavelength. That's our lambda. Oops, let's switch colors. Lambda, 630 nanometers is 6.3 times 10 to the negative 7, 1 meters. It says the screen is 3 meters away. That means our L equals 3 meters. The distance between the first and fifth dark spots is 12 centimeters. So now if we go to the picture, let's say that this is our first dark spot. Then we've got a second, a third, a fourth, and the fifth dark spot. If that distance is 12 centimeters, the first to fifth, really, first to fifth is the same as where the fourth bright spot is. So even though it's describing dark, the first dark to fifth dark is the same as the distance from, if we had measured, say this guy here was a central maximum, that's the same distance as to where the fourth bright spot is. So we can use n equals 4 with that given y value. If you think back to our conditions, dy over L equals n lambda. If we crunch it out, the numbers work out kind of nicely. We get a d value of 6.3 times 10 to the negative 5. Some people, when they see this question, will do it a little bit differently. If the first to the fifth is 12 centimeters, they'll divide that out and say that's equivalent to an n equals 1, and then divide the y distance by 4, which is 3. If you go through the math using those numbers, you'll get the exact same d value. It's equivalent, just a slightly different way of thinking it through.